Let's look at some issues of climate and food safety. And surprisingly, here is some research from a Gates Foundation funded program that looked at the impact of malaria on agricultural households. And of course, that means impacts on agriculture and food and nutrition. So it's just a schematic, but nonetheless, it's very useful to look at. Here we have malaria, which can affect decisions, crops to plants, agricultural inputs and technology, which gears up with agricultural households and their decision processes. So increased support for vector control can decrease malaria and improve health, which can improve decisions on crops to plant, agricultural inputs and technology. Okay, that can lead to increased productivity, increase in harvest value, and household income can increase and positively affect these things. It can also improve nutrition security and of course health. So there is this complicated interaction that's possible, especially in sub-Saharan Africa and other parts of Africa and other countries where malaria is still a devastating disease that can affect at the wrong time in terms of agricultural activities, rainfall, mosquito population, and so on. Extending that into broadly climate change, which includes warming, droughts, and floods, can affect agricultural production, including fishing, livestock, and other rural livelihoods, can affect dietary intake, which can affect food utilization and nutritional status. So dietary diversity and diet quality can be affected. Nutritional absorption and requirements are what we call food utilization, how the body uses it, which depends on food itself and water, of course, that you are consuming. That determines your nutritional status. But health is also directly affected, as we have been seeing with foodborne, waterborne, vector-borne, and zoonotic diseases. So food safety, water quality, and sanitation effects, which affect women's time taken for care and feeding practices, which affects the vulnerability to dietary care, affects diarrheal diseases, which seriously affects food utilization, body's ability to take nutrition from food. Gender norms also play into these things, especially in developing countries and poorer countries. Health outcome is also affected by vector-borne diseases and zoonosis that we talked about, which again through health can absorb food utilization and nutrition status. So this is a very nice schematic which links up all these socioeconomic and physical and climate factors leading to health outcomes and nutrition status, right? How does climate change affect food safety? We will look at a couple of slides. This is from the Global Climate and Health Alliance. Climate change can increase food and waterborne disease risks in many ways. We know that. Many pathogens, such as those responsible for cholera, are sensitive to changing temperature, rainfall, and extreme weather, which we have already looked at. This diagram summarizes some of the main mechanisms. So here we have climate change affecting temperature, rainfall, sea levels, changes in pathogens, growth, survival, and virulence. Changes in temperature, rainfall, sea level can affect contamination of crops by feces due to high levels of rainfall or flooding. Food scarcity can cause dietary shifts towards more unsafe foods, and water scarcity during droughts can adversely affect hygiene and sanitation. Again, these are general statements, but we must keep in mind these kind of linkages, because then that drive data needs to quantify these relations and the health outcomes. Okay, here are some examples of microbiological agents that could be affected by climate change and variability and mode of transmission to humans. We have seen some of these already. We're looking at bacteria, virus, and parasites in the next three slides. So Salmonella, Campylobacter, Vibrio, E. coli, Anthrax, Clostridium, Yersinia, Listeria, and Leptospira, with hosts ranging from poultry and pigs, poultry, shellfish, fish, cattle, livestock, birds, rodents, pigs, livestock, and all farm species. And these are the modes of transmission to humans: fecal, oral, ingestion of spores through environmental routes, water, soils, and feeds, associated with outbreaks after droughts, handling of pigs at slaughter and is a risk to humans. In the northern hemisphere, listeriosis has distinct seasonal occurrence in livestock, probably associated with feeding of silage. Leptospirae, shed in urine to contaminate pasture, drinking water, and feed. Some of the examples of viruses we have seen: Rift Valley fever, Nipah virus, Hendra, hantavirus, hepatitis E, encephalitis tick-borne virus. With the various hosts we have already talked about: livestock, wildlife, bats, pigs, rodents, sheep, goats. Mode of transmission: blood or organs of infected animals, handling of animal tissues, unpasteurized or uncooked milk of infected animals, mosquitoes, hematophagous flies, directly from bats to humans through food in the consumption of date palm sap, for example. Infected pigs present a serious risk to farmers and abattoir workers. Secretions from infected horses, aerosol routes from rodents, outbreaks from activities such as clearing rodent-infested areas and hunting, fecal, oral, pig manure, and unpasteurized milk. Some examples of parasites: tapeworm, liver fluke, protozoan parasites, Toxoplasma gondii, which is very famous for coming from cats, Cryptosporidium, and Giardia. The hosts here range from cattle, sheep, cats, pigs, cats and dogs. Fecal mode of transmission range from fecal oral, eggs are excreted in feces. Cat feces are a major source of Toxoplasma gondii. Handling and consuming raw material from infected sheep and pigs. Fecal oral, waterborne, oocysts are highly infectious and with high loadings. Livestock feces pose a risk to animal handlers. Fecal oral transmission and waterborne diseases for Giardia. You could take a dog to play in a nearby water body, and it can come back with Giardia because it's a good host for Giardia in the water. Okay, as a parasite. I think it's also known as heartworm. The other thing that's happening with increasing temperature is, of course, mycotoxins, which are fungi naturally producing these toxins. So biological factors like susceptible crops, compatible toxigenic fungus, which depend on environmental factors like temperature, moisture, mechanical injury to the crop, and fungus. Harvesting, crop maturity, temperature, moisture, detection and diversion can be an issue. It can happen during storage where temperature, moisture, and detection divergence are missing. Can be transmitted to humans and from animal products to humans as well, and also in distribution and processing. Okay, so these are factors affecting mycotoxin occurrence in the food chain. Mycotoxin, again, coming from many fungi, mold, and so on, which are very much dependent on these environmental factors, which are again dependent on climate change as well as other human factors like storage and so on. The other big thing we have to look at next is how agriculture itself affects the environment. Agriculture is not a small part of the overall greenhouse gas emissions. In addition, agriculture uses lots of land, can cause land degradation, and it can contaminate water and of course use a lot of water for food production as well. Okay, so I hope you are following the thought process about how food availability, nutrition, food security, stability of prices, and so on are going to affect nutrition, food utilization, which means health outcomes. So we're not directly talking about diseases, but we are talking about bodies nutrition status and how that makes us vulnerable to disease outcomes. Okay, in addition to these parasites, viruses, and so on, and mycotoxin, which can affect food and affect food safety